In this video, we'll be talking about an agricultural case study that deals with own price elasticity of demand. So to give you some background information, this is a study that took place in Texas, where it's common to grow cotton and corn in what's called a rotation. Now, rotation is when farmers use an area, we'll say a field, to grow one crop in one season or in one year, and a different crop in the next season or the next year. So they're not planting the same crop back to back in the same place. They plant different crops in that same place. And they do this for several reasons, including soil nutrient availability and to control pests and diseases. Texas, as you might imagine, is a pretty dry growing climate. And much like we see in California here, water scarcity is becoming more and more of an issue. One of the ways that policymakers have of controlling the use of a natural resource is through controlling its price. They may institute a policy that raises the price of water to lower the demand for water, to decrease the amount of water that we all, as water consumers, are using, and therefore achieve conservation goals. So the researchers in this study wanted to look at whether farmers would respond to an increase in the price of water by decreasing the amount of water they used for irrigation and adopting water conservation methods. They basically wanted to find ways to promote water conservation in this region and to know how effective price policies would be in doing this. So the researchers asked this question: will raising the price of irrigation water for farmers increase water conservation efforts? Now, we've talked quite a bit about demand in this class by now, so we might assume that, yes, as the price of water goes up, the demand for water will go down. However, what they found turned out to be a little bit more complicated than that. What they found was that it depended on the crop. For cotton, farmers who are growing cotton, they did respond by cutting back their irrigation. But for corn, they did not respond to that. So for corn, they still irrigated the same, even though water was more expensive. The same farmers were willing to cut back on their water use for cotton when water was more expensive. So here's a question for you to answer in the top of your notes, the same notes you used for the last lecture. For which crop is water demand elastic, and for which is it inelastic? Go ahead and pause the video and do this now. Oops. Now, there must be a reason that farmers are consistently making these choices, right? To respond by decreasing water use for cotton, but not for corn. Maybe it's that cotton plants are able to cope with more water stress, meaning that they can handle being a little dried out and farmers still get a profitable crop. But maybe corn needs all that water to produce well. Or maybe it's because farmers get a higher price for corn than they do for cotton. So even with the extra spending, they still make the profit on corn, whereas the price of cotton is too low to accommodate the higher price of water. I don't know exactly what the answer is, but the point is that it's really important to recognize that farmers hold a tremendous amount of knowledge about their crops, about their regions, and about their markets. And this is knowledge that they've acquired over many, many years of experience, or in some cases, generations of experience. And it's an important piece of the puzzle that's often overlooked when it comes to policymaking. This is knowledge that is unique to farmers and is not necessarily understood by policymakers or folks working in resource conservation. So there's implications here for policymaking. Price elasticity of demand values are metrics that policymakers and economists already work with regularly. It's something that they understand and can integrate into their work. So it could be a really valuable tool for communication when it comes to designing policies like this. Now, the results of this study imply that one size fits all policies, like one that raises the price of irrigation water across the board to promote water conservation, they may not be all that effective. And in fact, they may end up hurting farmers. By using price elasticity of demand, we have a quantifiable piece of data that can help policymakers to better understand how complex agricultural systems really work, and not just how they should work based on overly simplified models. If farmers are unable to decrease their water usage for corn, and they just have to pay the higher price, then this isn't really a very effective policy, right? It's a lose-lose situation. The policy is not achieving its goals of water conservation, and farmers are being hurt by the higher prices. So this suggests that maybe we need to think about policymaking in a more specific way. Maybe natural resource conservation policies need to be more regionally specific, more crop or system specific to be effective. And remember all that knowledge that farmers have? Well, that needs to be understood and communicated by policymakers. Farmers need a seat at the table in these decisions. And if we can take that knowledge that farmers have from all their decades or generations of experience and translate it into metrics like price elasticity of demands, concepts that policymakers already use and are familiar with, that could be a really powerful tool for designing policies that work for everyone. Now, there are a few other things that this study brought up for me that I think are really exciting. Because we've studied the principle of scarcity, we know that the limits of natural resources, just like everything else, are finite. They're not endless. We'll run out at some point. If you follow environmental concerns, you're probably aware that many of the citizens of Earth, including a great number of scientists, are incredibly concerned about the ability of humans to inhabit this planet in the coming centuries and even decades because of how rapidly we're using up our natural resources. If we use metrics like price elasticity of demand, that could help us to make decisions not just about policies, but about how and where we direct technology development. So crops or regions that have very inelastic demand for resources like water, they are the ones where technology development is needed to help support that crop, like developing more drought-tolerant varieties of corn. That's where those technologies will do the most good, in the places where the resource use is the most inelastic. Now, similarly, these metrics might also help us to understand when we might be growing crops in a certain region or in a certain system and using certain methods that is just not suited to the needs of that crop. So what if we use these decision-making tools of economics to help us design agricultural systems that are really well suited to the environmental conditions and resource availability of our regions? So I think this is a really exciting nexus of economics and sustainability. And it kind of shows that the study of economics isn't all just about prices and markets and money. It's also about these finite natural resources that we need to protect and that we need to start circulating rather than just using up. So I hope this gets you guys thinking about the role of economics in designing a sustainable future. So that's all for now. Think about this one for a while, and I'm really excited to see what you guys come up with in your discussion posts.